Alright, hello everyone, welcome back. So in today's class, we will continue to discuss about the advanced indexing for database systems. If you still remember, in the last class, we have introduced the basic information about advanced indexing already. We'll take this document retrieval as an example and to show how to construct an inverted index, which can speed up the processing time cost of database systems. However, here in this class, we plan to take this general database system to illustrate the techniques we can use to speed up the query process. To be specific, we will introduce two basic data structures which can model the query search process in database systems. The first one is called KD tree or the K-dimensional tree, and the second one is called quadral tree. Both of them are the tree structure diagrams or algorithms which can be used to help us speed up the query process in database systems. Okay, so before we introduce the KD tree, I'd like to provide a very brief introduction for the multidimensional index first. So if you still remember, right, before when we are defining the relations in database systems, we define the relation as a schema. And in the schema, we can have multiple attributes. So it depends on how we treat this kind of relation, right? Here, if we treat these attributes of a relation as a coordinates, then actually the tuples in the relation or the records in the relation will denote a bunch of points in a space, right? And the points, the coordinates will be all the feature values or the attribute values of the tuples. And then the location will be defined by combination of these coordinates together, right, in the space. So as seen here, when we see the attributes of a relation as a coordinate, then a database store a point state in higher dimensions. So here, this indexing can have multiple keys normally, right? And we show some examples in this page. For example, if we model the spatial database or the GIS database, then we can have multiple attributes for each point in the space, right? And we can also use to model multimedia database as well as medical applications in database systems. So if we treat these attributes of a relation as coordinates, then the query process with the multidimensional indexes will be very interesting. And the query can be supported in different versions. In this page, we show some examples. Now we can do some partial match queries, right? And for some of the query, we can specify the value of a subset of the dimensions or the attributes, right? In other words, we have so many attributes. However, we can specify only a few number of the attributes instead, right? Which is called partial match of these attributes. And as to the remaining attributes, we can just ignore them. It doesn't matter, right? And we can specify the values of these attributes. It will be help us to find the points or tuples matching our attribute values. Or we can do this range queries. In other words, we can give a range of values for each dimension. And for each attribute, we can give a value range, right? And we want to find the data tuple matching, the values within the range. Or we can do the nearest neighbor queries, and we can ask for the closest points to the given point. Given a data point in a space or in a dimension, and we want to find a data point which are close to our given data points, which is called nearest neighbor queries. So these are the queries we can do or we can study based on multidimensional indexes. And we also show you with the example. And here let's assume we have a relation. The relation name is called customers. And for the customer inside it, we have multiple attributes. The first attribute we have is salary. The second one we have is the number of children the customer has. And the last attribute will be the age of the customer. Right? We have three attributes. Here, if we model these three attributes as coordinates, for example, we can treat the age of the customer as the x-axis. We have x-axis denoting the value of the age of the customer. And we can also treat this y-axis as the number of children the customers have, which can be some numbers, right? As to the z-axis, we can denote it as the salary of the customer. Then all the customers in the relation customers table will be lying in this dimension, this space, right? With x, y, z axis denoting the age, children number, as well as salary, right? So when we do a range query, for example, we can specify the value range of the target customer we plan to find. For example, we want to find a customer whose salary is within the range from 3K to 4K. and the children number is in the range from 2 to 4, and the age is in the range from 25 to 40. In other words, in the feature space, we want to find the data points of customers which are lying in this cube, right? For the cube inside it, we have the x dimension to be 25 to 40. The y dimension will be in the range from 2 to 4, and the z dimension will be in the range from 3k to 4k, right? For a custom whose attribute value are in this range, then it will be lying inside this cube, right? And we can return them as the target results for the query. So this is the range query we can support based on this multidimensional index.